In today's lesson, we're going to talk about elements and isotopes. Our goal here for Learning Target 2.2 is to learn about the composition of atoms and then what sorts of information we can get from the periodic table to help us to determine some of the elements' composition and other information about how those elements will behave. So how do we distinguish between elements? So here, elements are composed of atoms with different numbers of protons. So when we're looking at different atoms on the periodic table, it's going to be the number of protons that's going to distinguish between them. So for example, here, lithium may have 3 protons. Let's say the blue dots are protons. So lithium has 1, 2, 3 protons. Whereas carbon has 1, 2, 3, 4, 5, 6 protons, and that's going to identify those atoms. So the number of protons really determines the element's identity. So those number of protons are very, very important. So that's definitely something as we go through the year, you're going to want to pay close attention to. So when we look at the periodic table, when we look at one of these squares on the periodic table, we can get a lot of information about the element, both from just the information in the square and based on its location as well. We're going to talk more about location later on in this unit, but for now, let's just take a look at this square. So we have a letter or a combination of 2 letters that give us a symbol for that element. This is carbon. I'm always going to give you guys periodic tables that have the name and the symbol on them. I don't expect you to have memorized all the symbols for all the different elements because some of them are kind of weird. So here C stands for carbon. The number above my element symbol, this is telling me the atomic number, and we're going to talk more about this in a minute, but the atomic number tells me the number of protons that every single atom of this element will have. So any atom of carbon that I look at in the universe will always have 6 protons, because remember on the last slide, we said that the number of protons is the identifier for the atom. So every carbon atom will have 6 protons, and 6 is the atomic number for this element. The number below the symbol, this is my atomic mass. Typically, we're going to see 2 or 3 decimal place values on the end of this number. This is an average of what all the isotopes, we're going to talk about this in a minute. So this is an average mass of all of the atoms of carbon on Earth. So if we take a sample of carbon atoms on Earth, the average mass is 12.011. And when they're arranged on the periodic table, we arrange them in order of increasing atomic number or in order of increasing protons. So with each atom, we add 1 additional proton to the nucleus. So when we're looking at the symbols, the names and the symbols of the elements, it's important that you're using the appropriate conventions in chemistry so that if I'm publishing a paper or if I'm writing even just a chemical equation to submit or to give somebody else a chemical reaction that they need to do, it's important that you're using the appropriate symbols and writing them the correct way. So every symbol is going to have 1 or 2 letters in the abbreviation. So here we see carbon is 1 letter, magnesium is 2. Anytime you write these symbols, the first letter of the abbreviation should always be capitalized. This is super important. So magnesium should always have a capital M in front. If it's a 1-letter symbol, then it should have 1 capital letter. The second letter is always going to be lowercase as well. So this is important. This G in magnesium should be lowercase. So for a lot of elements, like magnesium, there is no element G, so it doesn't really matter. But if we look at cobalt is CO, but if I were to write capital C, capital O, this is carbon and oxygen, whereas this is cobalt. So those are 2 completely different things. So it's important that the first letter is capitalized, but the second letter remains lowercase. I will take points off if I see this on any homework assignments, any graded assignments. I will take off points if I see incorrect symbol. Alt is, So some of the symbols on the periodic table don't really seem to make sense based on their name. So here are just some examples. So gold, its symbol on the periodic table is actually AU. And the reason for that is because the original names of these elements were in Greek or in Latin. So it's the Greek or Latin names that we get these symbols from. So gold was aurum, lead is Pb, lead was plumbum. Sodium is a really common one that we use a lot, is Na. Natrium was the original name, and iron is Fe. Ferrium was the original name. So you guys will get kind of used to these. There's some of them like sodium we use a lot, so you'll recognize sodium as Na, not S. S is sulfur. So just some things to keep in mind and be careful about. So here's our atomic structure. Again, this should be familiar to you. So we're going to have our protons, our positively charged particles, and our neutrons, our neutral particles, are going to be in the nucleus. And then my electrons, my negatively charged electrons, are orbiting around the outside. We're typically going to be thinking about the Bohr model. So electrons orbiting in orbitals or shells. We also refer to them as energy levels around the outside. All right, so how do we find all of this information? How do we find information about proton number, neutron number, and electron number? Electron numbers and really determining what's going on with electrons is going to be one of the most important things we can do in chemistry, because that's really going to determine a lot of the behavior of elements. So we need to be able to figure out these numbers based on the limited information that's given to us just in the square on the periodic table. So first, we've talked already about finding atomic number. In order to determine the atomic number of an atom, we're going to, in order to determine the number of protons, we're going to use the atomic number, whatever it is on the periodic table. So if I tell you to determine the atomic number of carbon on the periodic, determine the number of protons of carbon, the atomic number for carbon on the periodic table is 6. So carbon would have 6 protons. The atomic mass is going to be the average mass of all the naturally occurring isotopes. So this is the number that we see on the periodic table. This is a little bit different than mass number, so that's something to keep in common. The atomic mass is the number given on the periodic table, whereas mass number is rounded from the periodic table typically, or it will be given to you, or you can calculate it if I don't give you the mass. This number, this mass number, is calculated by taking the number of protons plus the number of neutrons that an element has. And really what we're measuring this atomic mass in, it's in AMUs, or atomic mass units. Okay, so one proton has a mass of 1 atomic mass unit, and one neutron has a mass of 1 atomic mass unit. So if I tell you, for example, that the mass number for carbon is 14, okay, I can start to kind of figure out some other things. So if I look here and I kind of have carbon 14, if I have carbon that has a mass of 14, and I know that carbon's atomic number is 6, so the number of protons is 6. So protons plus neutrons equals the mass number. So my protons are 6. My number of neutrons is unknown, and that's going to equal my mass number, which in this case is 14. So I can solve for the number of neutrons here by subtracting 6 from both sides of my equation, really subtracting 6 from my mass number, and that gives me 8 is my number of neutrons in this particular atom. So you guys will be able to solve problems like this given some other pieces of information. All right, and then finally my number of electrons. This is really easy to determine as long as my atom is neutral. So if the atom is neutral, the number of protons is going to be equal to the number of electrons. So if I have, again, if I have carbon, carbon has 6 protons because it is atomic number 6. If it's a neutral carbon, that means it also is going to have 6 electrons. And we often show electrons as a lowercase e with a little negative superscript on there. So E minus means electrons. So here there's 16 electrons, or sorry, 6 electrons in this particular atom. if it's neutral. If the atom has a charge, for example, if the charge of the atom is +1, that means there's one extra positively charged particle, which means there's one extra proton. So here, if there's a +1 charge, if there's 6 protons, there's only 5 electrons in this case, because there should be one extra proton, or one proton extra than electrons. If there's a negative charge, so let's say there's a -1 charge on my atom, in this case, that means I have one extra negative charge, or one extra electron. So if there were 6 protons, if there were a -1 charge, I would have 7 electrons instead. So something to look out for. Atomic mass that we see on the periodic table is the average mass of all the naturally occurring isotopes of that. An isotope, and we talked about this a minute ago, the atomic number or the element. An isotope is an atom of a specific element that has a different mass than others. And really it's going to have a different mass because it has a different number of neutrons. So when we look at the mass of the particles in our atom, electrons have a mass that's so small that we don't even really have to pay attention to it. Proton number cannot change because that is going to determine what atom we're looking at. So the only thing that can change that will actually change the overall mass of the atom is the number of neutrons. So here we have oxygen that has 8 protons and 8 neutrons. So that has a total mass of 16. So down here on the bottom, I have an oxygen isotope that has a mass of 16. So we see that as a superscript on the left-hand side. Here I have 8 protons and 9 neutrons. So here I have an oxygen isotope that has a mass of 17, and then here I have 8 protons and 10 neutrons, so I have a atomic mass here of 18. So all of these are oxygen. These are different isotopes of oxygen, which means they're atoms of oxygen that have a different mass because they have a different number of neutrons in their nucleus. There are a couple ways that we can write in and give information about specific isotopes, and we call this isotopic notation. So we can either write the element symbol and then a dash and then the atomic mass of that element, or the mass number of that element, or we can write the symbol and then we can put the mass number on the upper left-hand corner as a superscript there. So either of these would be telling us that this is sodium that has a mass number of 22, sodium with a mass number of 22. So if you see either of these notations, this number is telling you the mass number for this the specific atom of sodium. All right, finally, there's this term valence electrons. It's going to be very important for us as we move forward through this unit and really throughout the rest of the year in chemistry. All of chemistry, except with the exception of nuclear chemistry, involves the electrons, or kind of how the electrons are interacting with other atoms, specifically the electrons that are on the outermost energy level, and these are known as valence electrons. So electrons are going to occupy different energy levels within an atom. So typically when we draw our atoms, we're going to draw these in kind of a Bohr model type of structure. So here are my electrons along these orbits around my nucleus. The rules for drawing these Bohr models we're going to talk more about in our next unit, but I have my atoms are orbiting and or electrons are orbiting in my atom, and the electron on the very outer orbital, or the very outer or highest energy level, this is going to be the electron that actually interacts with its surroundings. So this is my valence electron. So in this case, there is one valence electron in my atom. So something to keep in mind here. So again, like I said, the last energy level consists of what's called valence electrons. These are the electrons that will be making the bonds between itself and other atoms. So these are my bonding electrons. So these ones are going to be really important for us. All right, so if you guys have any questions, go ahead and leave them at the end of the video, and I'll see you guys tomorrow.